Hi, my name is Alex Williams, founder of the NewStack, and you are listening to the NewStack Analyst Podcast. We look at application development and management at scale. Docker Inc. is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Docker's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get to the show.
Hi, this is Lee Calico with the NewStack. I'm joined today with Benjamin Ball, editor of ebook series at the NewStack, as well as Nathan McCauley, a director of security at Docker. Nathan, thanks for joining us on the podcast.
Great to be here. Thanks for having me.
So Ben, Nathan, we're what, like a little over a week out from DockerCon, fresh off that boat, so to speak. There were some great views up in the the Space Needle. I particularly enjoyed the conference, but Nathan, just really good to catch up with you. I know security has been a hot topic around containers, but Docker specifically for some time. One of the takeaways that I took from main stage as Ben was up there was just this notion that security seems to no longer be one of those hindrances to kind of the whole Docker conversation at some of these organizations that are adopting, but it looks like security is starting to lead some of those conversations and bring people towards Docker. Has that been your experience, or how has that manifested itself?
Yeah, I think it's there's two parts of that. The first part about security kind of leading a bunch of these conversations is understanding what Docker is. For a lot of people, there was misunderstandings about what the technology is, what it does, and just the general newness of any technology. Questions around security arise. What we're seeing is over the last about 2 years of investment from Docker, we've built a lot of very sound foundational pieces into the platform, and a lot of folks are starting to see that come through in the platform and the controls, be it audit and risk and compliance, but then also like foundational security that is improved tremendously. In addition to that, what many organizations are seeing is a fundamental shift to a DevOps mentality. And with that DevOps mentality, they're realizing that they need kind of a lever to implement security controls. And basically at the exact moment when folks are looking for a way to implement controls into their DevOps processes, Docker has come along with a fantastic solution that helps with DevOps, but brings all the security and control into that pipeline. And so many organizations are seeing it as a way to have security be part of the new process, where prior to DevOps, it was more of a human-oriented process. They're now realizing that the tooling that can come along with Docker and containers allows them to have a lot of the same kinds of controls they want and need.
Well, that tooling is significantly changed since sort of the inception of Docker itself. And you guys, you and your team have been pretty busy, so kudos to you.
Thanks.
I noted that of the 112 release, which was heralded at DockerCon, it seemed like there were 4 cornerstones of the release, so to speak, and not one of those, and not an insignificant way, was security at large. I think one of the mainstay features was this notion of cryptographic node identity. And I know that node identity, or nodes as a construct, aren't the only thing that have identity in Docker land. Users have identities, images have identities, nodes do. Can you take us through kind of identities and just and what is cryptographic node identity?
Sure. We felt that it was a pretty important piece to get built in right from the get-go with our integrated orchestration system. Just talk briefly for your listeners about the context behind what is in Docker 112. The big change that happens in Docker 112 is that Docker, out of the box, has capability of doing clustering and orchestration of many containers. And so it's a fundamental shift where all of a sudden you're thinking about many Docker engines working together to schedule and run containers. And there's a lot been done there about how to make that extremely easy to do, extremely easy to set up. So basically, Docker Swarm init and Docker Swarm join, and all of a sudden you have a cluster. And so within that context, it turns out there's a bunch of security questions that you want answered when you have a system like that. And all roads lead to having some identity for the nodes. All the kinds of stuff that you want to build on top of a swarm of machines, a cluster of machines, have to do with who is this machine, what is it allowed to do, and what is it not allowed to do. And so we decided from the get-go to take that extremely easy to use Docker Swarm init, Docker Swarm join, and integrate extremely strong crypto into that. And what I mean by that is we have basically implemented a very easy to use PKI that is actually so easy to use that in the initial demos we did, even here within Docker, we didn't say anything about it. We just turned it on. It was on by default, and all of the commands look exactly the same. And the reason the commands look exactly the same is because that's all built in by default. There's no way to turn it off. Every Docker engine that is part of a swarm gets a TLS identity that allows us to build a bunch of stuff on top of that. Once every node has a TLS identity, you can build really interesting stuff like automatic encryption between all of the communication between the nodes in the cluster. In addition to that, you can make decisions about what workloads will run on which hosts. So you had some portion of your hosts that were only allowed to do sensitive operations, and you wanted to cordon off those hosts and say, only allow these ones to do, say, payment processing, or only allow these to do encryption or decryption of payloads. You can set up policies like that, all based off of the node's identity. So that's just a couple of things that we kind of already have built on top of that, but we definitely imagine that the cryptographic node identity that we've built in there will kind of be this gift that keeps on giving. So there's definitely more to come, but we're already excited about what we've managed to achieve so far with it.
Well, it sounds like, whether you're a developer or you're an operator, I think that's just the way that you want security. I mean, it's just built in. You don't even necessarily know that it's there. The communication is secure by default. You guys have chosen what I assume to be kind of your best practices around those configurations. If I read correctly, if I understood correctly, that's like, one of those defaults is rotating keys certificates every 3 months, I think.
Yeah.
So that's just a beautiful thing. But if we talk about like the PKI that's in there, that certificate of authority and the certificates that are generated, for those that do wear a security hat and do have their own policies in place and they need to adhere to for their organization, like you started to get into, sounded like how you could use constraints and filters from as scheduling strategies in Swarm to be able to define what sensitive workloads can go to. But I guess my question is, can you talk a little bit about for someone who does want to open up that box and bring in their own policies, either around handling certificates or how they're generated, how they're issued?
I think it goes to a fundamental heart of what Docker is about. And one of those core tenets of things that we believe is that we have this mantra that's called batteries included but pluggable. And what we mean by that is our products and our solutions ship with a default battery, something you can use outside of the box to get the security or the storage or whatever feature it is needed. But you have a pluggable backend that you can use for other customization. So in the case of cryptographic node identity, the main piece that I imagine organizations are going to want to have pluggable is the CA itself. Many organizations have built up their own CA that they have stored securely. They're comfortable with all the processes and policies around that, and they may want to use that CA. And the reason that would need to be pluggable is because by default in Docker 112, the Swarm master itself acts as the CA. So internal to the cluster, the master nodes act as the CA and act as the registration authority to issue the certificates to each of the nodes. So the way we built that was we built it with a very simple interface. It basically uses what's called certificate signing requests. Certificate signing requests are a totally standard piece of infrastructure within technology stacks. And so that's going to be the integration point. Is you'll be able to plug into your own CA if you want to by using the CSRs that are generated by each node as it joins the swarm.
Oh, that's fantastic to hear. Yeah, there's no doubt in almost every environment that Docker goes into that there's an existing investment into incumbent systems. A lot of times that's a PKI system.
Yep.
Well, that's all very exciting. Actually, the whole simplicity of getting a multi-host environment up with Swarm embedded is just a really beautiful story as well. So we've been talking about security in and around your on-premise software, the software that customers run as they things like Docker, Trusted Registry, and the like. But you guys also have a significant effort around SaaS offerings between UCP and obviously as you run and host your own infrastructure, that needs to be secured as well. How do these two worlds come together?
Yeah, I think it's actually a really interesting thing about the job of security at Docker. Security at Docker is not just the public-facing kind of product development, feature development that happens in the open source. It's also securing the Docker Hub infrastructure, the Docker Cloud infrastructure. And as we build more solutions, for example, Docker security scanning, all of those run in a hosted environment. So in the same way that other startups are building SaaS offerings and needing to secure that infrastructure there, we ourselves need to do that. And a lot of what is driving our feature development and our product development in the open source is the needs that we have inside of the Docker Hub and Docker Cloud infrastructure services. So to give an example, the Docker Cloud and Docker Hub, we run a bunch of containers. And a problem that I had as the person responsible for security at Docker is, how do I know whether or not we're running vulnerable software? So it turns out if we solve that for ourselves, we can also solve that for everyone else, productize it, and then use it ourselves while it's being developed. So it should be no surprise at all that we were using Docker security scanning to scan and validate our own containers before we rolled them out. And that's just one example. There are tons of examples of stuff we've put in the open source that was something that we wanted for operating Docker Hub. Take user namespaces, for example, or seccomp filtering, the newest isolation features that came out as of Docker 1.10. We wanted those to be able to more adequately secure our infrastructure. So built those and helped drive the process there. So you end up in these situations where there's this very good feedback loop where a company that builds infrastructure tooling like Docker also uses it themselves, and I wouldn't have it any other way.
You mentioned seccomp, and I just can't help but kind of, it's a key word for me. But between the seccomp profiles and AppArmor profiles, as a user of the Docker for Mac, which is also another beautiful piece of software. As someone who, in order to get into Moby, the Docker for Mac VM that runs on Xi, I think there's some nuances in terms of SSHing into that VM itself, but outside of SSHing or outside of being it on the host itself, is there any other way that Docker provides to manipulate like AppArmor profiles or seccomp filters?
I'm not terribly sure how configurable that is in Docker for Mac. Docker for Mac runs with this Moby VM that is basically a derivative of Alpine that we're working on here at Docker. And in general, the notion is that running on Docker for Mac should be the same as it is running in production. That's kind of the whole promise of Docker is you can develop on your laptop and then run in production, and it's basically equivalent. The goal is definitely to allow any kind of development on your laptop the same as it would be in production.
One of the things I've seen Solomon Hykes talk a lot about is the usability of software, obviously, and specifically talked about with security is how users will either ignore them or not use them. Is that one of the reasons why so many of these security features are out of the box default?
Yeah, a lot of what you can see in our security philosophy is secure by default is absolutely the most effective way to get security to actually happen. And in many cases, it's possibly the only way that security will happen. And so philosophically, we've seen this in the case of, say, web browsers, the default security that's built into web browsers, default security that's built into platforms like the iPhone, where it's built in by default and there are basically no options that are available to you. It's just on by default, works as intended, and kind of just happens behind the box. So in the cases where it is possible to just do the right thing, we kind of feel like there's no reason to have configurability there. So just build it in, build it by default. And you see this in a bunch of our decisions. For example, default filtering in many cases of seccomp filters, AppArmor, SE Linux profiles on the particular hosts, capability dropping, all that happens by default because those are just good defaults to happen. In addition to that, you see things like Docker 112's cryptographic node identity, where out of the box security happens and there's no option. I think this is a pretty important lesson that the security industry has learned over the past few decades, really, but especially the past few years. And so what we're seeing is actually that being introduced into Docker, rolled in by default across many of our products, and you'll continue to see us do that because of the high leverage nature of people moving into Docker and getting that security for free is going to continue to be something that warms our hearts because more infrastructures are more secure because of being deployed inside of Docker. And you're going to see more people moving to Docker because they realize they're going to be getting all the security out of the box.
That's kind of segueing into something that I was curious about. We've sort of seen in our own research that container adoption is often the obstacle to container often cited as security. It may be one of the top concerns anyway, maybe not the one thing that's keeping them from using containers, and certainly not necessarily just Docker. Do you see that these increased security efforts and maybe this like baseline appeal to addressing security for users is actually helping Docker attract more users, or do you think this is just a necessary move forward?
There's a couple of ways to look at this question. In many cases, I think that the concern about security is really the concern about Docker security is really a proxy for the overall industry concern about security these days. It appears that in many cases the industry is understanding the security is something that need to be taken very seriously. At the same time as they're beginning more and more understand that a lot of solutions are inadequate to the task. And so with any technology transition, I view it as a sign of health of our ecosystem that people are asking these very tough security questions. And I welcome it for Docker, because I think what we're seeing with Docker especially is there's now this understanding of what the best practices ought to be for a number of different problems in the DevOps pipeline. And so when people ask these kinds of questions, what they ask is, why doesn't it do this? Even if there is no other solution in the world that is that good, they're setting that expectation really high. And I'm really glad that that expectation is being set high across the industry at large. And Docker is one product that is really benefiting from that high expectation. On the other side of that, they're seeing the work that we've done for the past 2 years or so on meeting those expectations across the problems that we started to tackle. Cryptographic node identity is one. Docker content trust, where we have the basically the most sophisticated signing and update verification system that has been rolled out in any kind of software. All of the isolation primitives that we've built in by default are seeing that benefit. And so people kind of see the trajectory. Everything Docker does in terms of security is very good, very well thought out. We're going to continue to do that. And so that trend is appealing to many customers, and they come to understand, like, hey, look, this company is taking this seriously and is going to continue to do so. I'm ready to move to Docker because of that.
It's good to. I think I really like that idea of if this is good for the industry for keeping the standards high for security and maybe higher than any other solution really is that's comparable. I wonder if that kind of user error component is a major part of Docker's considerations when you build in security features, the actual inherent security of the software versus, the systems of trust around users who are actually using it.
Yep. Yeah, I think I think thinking about it in terms of the skills shortage in software security is pretty instructive. The big companies, the big technology companies that can attract top tier security talent and large numbers of them and have budget for large teams, they're going to be fine. They're going to have software teams that understand these kinds of things. They're going to have folks that are very interested in figuring all this stuff out, and they'll take the effort to get everything right. In many cases, build their own solutions. But that's not every organization. And the reason that's not every organization is because there are so few talented software security engineers in the industry, and there's not any end in sight to that talent shortage. So for many organizations, they rely on vendor solutions to do security correctly. And so when we think about how we build things, as much as we can, we don't want to have our products have any sharp edges. If you have a sharp edge where you can get cut by doing something incorrectly, then we want to help folks get around that. You can see that with something like the Docker bench. There are a lot of ways to get up and going with Docker, to install Docker on a host and get it running. But it turns out there is a good way to do it. And what the sys benchmark has done is come up with about over 100 pages of recommendations on how to set that up properly. Now, some of those aren't built into Docker by default. So the mitigating control that we've done there is make Docker bench and have that as a way for people to very quickly see, are they meeting the best practices guidelines that are available. Ideally, all of those things would be default. And as we build new features, you're going to continue to see them put in by default, so that there need not be a recommendation, because the recommendation is just use Docker.
That's a fantastic goal, Nathan. That's great. And just for those folks that might be listening that aren't familiar with that benchmark, there's an organization, the Center for Internet Security, puts out a number of different papers, if you will, or positions on various topics. One of those is Docker security itself. I know yourself and some of your team have been instrumental in helping publish those best practices. And then you guys have also, like you said, turned around, also helped produce a set of tooling. I think for the most part, a very convenient set of bash scripts that can go and sort of qualify your environment against those recommended best practices. And so, just to regurgitate what you said, is that over time, you're looking, like a goal for you guys is to essentially eliminate the need even for a paper like that, because it's just built in, going back to your philosophy of secure, inherently secure. So that's a beautiful philosophy.
Now let's take a quick break before we get back to the second half of the show. Docker Inc. is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Docker's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Now let's get back to the show.
speaking of philosophies, you mentioned earlier sort of the notion that I think we were talking about Moby and the VM that comes on Docker for Mac and Docker for Windows, and the notion that configuration is done there, very portable, and that's part of the whole promise of containers and Docker itself is just portability. I've heard, and I thought I'd ask you if you've heard, as developers go to do that on their laptops and they port that into production, it's been suggested that we just run laptops in production. And so it didn't know if that's what you guys run over there for some of your SaaS offerings, or if the infrastructure looks a little bit different.
Oh no, we don't run laptops in production. It's kind of cool to, for example, in Docker 112, you can have an AWS host in the same Swarm cluster as a laptop running in the office. Now, just because that's possible doesn't mean that it's a good idea, and we definitely don't do anything like running production workloads on laptops. But absolutely, the portability of the ability to have it run the same in development as it does in CI and testing, as it does in staging and production, is critically important to us, and you'll see that philosophy carry through with Docker for Mac and any other additions that we build. For example, Docker for AWS or Docker for Azure.
I know we're half kidding here, but if we tease that out a little bit, we take a look at the cryptographic node identity. If in fact there's an organization that's running workloads in a Swarm cluster on AWS, for example, and someone wants to take their laptop and join it to that cluster, how does, we were talking about, the notion that communication between hosts in a cluster is secure by default. Can you walk us through the process of joining a laptop to an existing cluster and what happens?
Sure. So the scenario here is that let's say there's a Docker swarm that's already been initialized out in, say, AWS, and if you had network access to that same swarm cluster, maybe you're on VPN and able to access that, what you could do is do Docker swarm join. Now, by default, that is not possible because you need to supply a password in order to be able to join a swarm. And so by default, that configuration would be set up securely so that the swarm running out in AWS would not just allow anyone to join it. And the reason you don't want anyone to join is because it can get sensitive workloads. Once you schedule a money moving application, that becomes a very sensitive operation. You wouldn't want that running on someone's laptop. So the password will be necessary in order to be able to join. But if you did have that password, then it would be as easy as Docker swarm join, and then specify the host. Basically specify a host name and a port in order to find that swarm and be able to join it. So it is that simple, but we have what are called acceptance policies inside of swarm masters, which say what is the policy to join this swarm or not. If you're just trying to kick the tires and experiment with stuff, there is an insecure mode, but we expect everyone else to be running in a mode where you have to provide some sort of credential in order to be able to join up to a swarm master.
That makes a perfect sense. For those that are running swarm clusters in secure mode, they need to provide that passphrase.
Yeah.
As we take the next steps in kind of that joining process, now that, like you said before, the swarm masters are running PKI, their own PKI, their own CA. What's that process look like in terms of establishing the secure connection then between a new host that's joining an existing cluster?
Sure. So there's a bit of a handshake process where a new node, basically you could think of it as applies to join the cluster. And the application process is they will join they'll send a request to the swarm master, and they'll say, hey, I want to join. And if authentication is turned on, they'll be told, hey, yes, you may join. And then once they're given that response, yes, you're allowed to join this cluster, what the node itself will do is generate an ID for itself. It'll say, hey, here's my public key that I've generated, so you know exactly who I am and what I'm about. And they'll submit what's called a certificate signing request to the swarm master. Swarm master will see that, take it down locally, and keep that in its Raft consensus database. That'll let you know that node exists and ought to be scheduled jobs. In addition to writing it down, it will issue a certificate for it. And that certificate will be sent down, and then that certificate will be used for any communication within the cluster that node performs. So getting any kind of updates to the number of masters, any kind of other communication that needs to happen in order to schedule tasks will all be done over TLS with that TLS certificate. The other thing that the swarm master will do is automatically rotate that certificate for the node. And the reason we do that is because probably every ops team on Earth has had an outage where a certificate expired. This just is kind of the nature of the beast of TLS certificates. They need to have an expiration for a number of reasons. And so what we've done with Docker 112 and the cryptographic node identity is said, hey, look, we're going to have the masters automatically renew these certificates so that we can specify short expirations. And right now it's defaulting to 3 months. We think organizations may be able to be way more aggressive with that and take it down to days or hours. And the reason you may want to do that is this way you don't have to deal with certificate revocation lists or OCSP responders at all. You have short-lived certs. Once you take a node out of the cluster, you can just let its cert expire, let the swarm master know that it's now gone, and you don't have to deal with any permanent record of the revocations of certificates. So we think that's a pretty powerful construct that actually a lot of PKIs ought to be using. We're seeing it with things like Let's Encrypt, for example. Automatic rotation and short-lived certificates is really working well inside of the Let's Encrypt system. And so building that by default into Swarm's cryptographic node identity management was something we really wanted to do.
Nice. Well, I think I got all that.
Yeah.
Which is, very encouraging to hear that all of that's accounted for as just in that simple, swarm join command. So part of the thing that you mentioned there was this notion of an implementation of Raft as I think the leader election kind of consensus for swarm masters, swarm managers. Which leads me to kind of this next question around the certificate authority and the certs that are generated and issued from the active master. As that master might go down and another one, a standby comes up, how are certificates managed between managers as they may come and go?
Yeah, that's a good question. So all of the swarm masters, which you need to have a quorum of swarm masters in order to be able to properly do Raft consensus in the first place. So you need 1, 3, 5, etc., some number of them, and all of them are able to act as the CA. For example, if one of them dies because the disk fails or the machine goes down, you want the other ones to be able to pick up the task. So each of the swarm masters has a copy of the CA certificate and key, and it's encrypted with by a environment variable, a key that's in an environment variable that allows you to safely encrypt that when the key is transferred between masters. In addition to that, sometimes you'll need to promote a worker node into a master. And when you do that promotion process, it actually follows the same kind of approach that joining the cluster in the first place took, which was there's an acceptance policy. And the same kind of acceptance policy that you would use for whether you can join the cluster is specified for whether or not you can be promoted from worker node to master node. And so the master node, say one gets promoted and you specify a password that allows you to promote it, it will need to then get the secret information that it had in order to be able to do the task. So that'll be communicated over Raft to the new master. Within the swarm system, the masters are the only ones that do consensus. The task nodes themselves communicate just to the masters directly. And so the Raft information, even though it's encrypted, so it would be secure, is not even being sent to the worker nodes at all.
Got it. Very good.
Yep.
Nathan, kind of one more question, I think, before we wrap up. Kind of just wanted to ask if there was really a security roadmap or any kind of functionality that might be upcoming. Although I don't want to put words in his mouth.
You spill your beans, Nathan. What can we expect next?
Yeah, so I think what you can expect next is a lot of what we've built over the past year and a half is really coming to fruition now, and so you're seeing it integrated into Docker Cloud and Docker Hub. For example, Docker Security Scanning has been integrated there. Docker Content Trust is available on all the official images or on any of your own private or public repositories that you build as a user. You're able to sign and verify those. So what we're doing now is taking those features and integrating them into our commercial offerings. And those commercial offerings are Docker Trusted Registry and Docker Universal Control Plane. Together, they're Docker Data Center. So getting all those features built into Docker Data Center is a really important goal for us for a lot of reasons. We want to really enable all of those secure workflows that people are using on cloud. We want to enable those for on-premise users. So take an image, sign it, have other developers build on top of it, and then scan that image for any vulnerabilities. We want to get all those workflows built in really well in order to support the same kinds of controls that people want in their internal DevOps workflows. So a lot of it is going to be integration work over the rest of the year. But additionally, there's a number of big ticket items that people are looking for to be solved within the Docker ecosystem. And a lot of that, I can't say much about it, but it's going to be a lot of those things that come out of cryptographic node identity that we built into Swarm. We really want to do a bunch there to help with the orchestration features that are available there. So more around segmentation about what containers run where, and then the extremely big ticket item that a lot of people are looking for is how do I get secret information, cryptographic material, how do I get that into containers that are running inside of a cluster?
Yeah, just at an application level, right? Like for, sort of the canonical example being, how does my web server get the credentials to the database? Or, to the...
Exactly.
Oh, very good.
Getting that solved really well is really important to us. So it's something we're going to be looking into.
That's great.
Very soon.
Just essentially back on what you said about, there being a fair bit of integration work, bringing a lot of the security capabilities that you guys have in your SaaS offering and in the infrastructure that you run into some of those on-premise offerings. I mean, some of which is already there, but
yep.
I'll tell you what's encouraging about that is the notion, back to what you said before, is that you guys essentially eat a lot of your own dog food in terms of running and building those security concepts and capabilities in your infrastructure, and then once they've been baked and tried and true, then they flow down into the on-premise offering. So that's heartwarming.
Yep.
Here's kind of another question along that. And I think part of that roadmap question, kind of where's the focus for Docker security going? Is potentially helpful for ecosystem players that have filled in either various cracks that have been there, or just helped augment and push forward container adoption at large. I guess the question is, what advice do you have for either whether you think of them as players or partners or competitors, or how do they best walk the journey with Docker as you guys do what you need to do in terms of building in a lot of that capability out of the box, and
yep.
Help organizations adopt containers. How do those players best position themselves to continue to help?
Yeah, I think it's a really good question, and the reason I think so is because we are in the grand scheme of things, we're a relatively small team compared to everybody that could be working on Docker security. And my goal, kind of as the director of security at Docker, is to increase the security of everybody running their infrastructure. So with that goal in mind, it's not that material to me what our team at Docker builds versus what the ecosystem builds. What I will say is that we will continue to focus on the problems that are really best suited to a platform maker. So we'll continue to do things that are secure by default, built into the platform as security solutions. So cryptographic node identity, no brainer for us to integrate that into the platform itself. What is, I think, more interesting for the ecosystem is to take a look at how you can reimagine some security problems in light of the differences that containers provide. So a lot of the security solutions that you see out there, a lot of the big names in security, have as a fundamental assumption that you have a whole host, either a bare metal host or an entire VM that is doing a bunch of different things. And we've kind of broken that model philosophically with Docker. The philosophy with Docker is more around microservices, a small piece of code that does one thing and does it well and ships as a Docker container. And so there's a number of things that come out as conclusions once you think about the security problems in that light. And so I would say the best approach for many of the ecosystem partners is to look at what is different now that we're deploying inside of Docker containers. And once you figure out what is different, there's definitely opportunities for security products to be integrated with Docker that do a better job of securing applications. I'll give one tangible example. Many intrusion detection systems over the last 20 years have been unbelievably noisy because it's very hard to figure out what is right, what is known good behavior, and what is all of a sudden erroneous malicious behavior. Very hard to figure that out because you're dealing with your level of granularity is entire host or entire VM. That's hard. Docker flips that model on its head. It is much harder to figure out what a good baseline for an entire host, but it's not hard to figure out what a good baseline is for a Docker container. So taking Docker container image identity, figuring out which image it is, and generating a baseline of behavior for that, and then alerting on deviations from the norm, you have an opportunity for a very high signal intrusion detection system. It's based on that. And the good news is there are a number of ecosystem partners that are working on that problem. But that's just one example of ways that you can take the different approach that Docker container security has and come up with new solutions. And I think a lot of the stuff like that is going to provide a lot of value and a lot of effective infrastructure improvement based on that. So that would be my advice. Number one, go after it, solve the problems because there are plenty of problems that are going to be left to solve, but do it while reimagining the problem in terms of Docker containers. Don't just take the existing stuff and kind of port it to be Docker aware. Really think about how the philosophy of infrastructure has changed.
And then that's fantastic. It's a very positive outlook. Moreover, some good counsel for those players that are out there, so that it makes a lot of sense. There have been just a ton of fantastic things coming out in 1.12. You've spoken to a little bit of what to expect kind of over the next year. And I think with that, Ben, are we done hammering on?
Yeah, I think so. Again, thank you very much, Lee, for joining. It's really kind of me joining you, but and thank you so much again, Nathan McCauley from Docker. I think we learned quite a bit here.
Great. Thanks a lot, guys.
Docker Inc. is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Docker's perspectives on these timely and important topics in our latest ebook about networking, security, and storage. It's available for download at thenewstack.io. Audio editing and sound design for the Newsstack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.